I tell you, my view, this is the most exciting time to be an engineer that we've seen in decades or generations. There are so many new problems that no one has ever thought about before. We're building up some knowledge now, but there's new problems and there's new toys. There's new technologies that didn't exist before. So right now is such an exciting time to be an engineer. It can't think of a better age or era to be in it. So many new things that need new approaches, and there's so much blue sky out there.
3, 2, 1. 0.
Hello everybody and welcome back to another exciting episode of the Engineering Buzzcast. My name is Jacob Primus and I'm joined here today with my good mate and co-host Daniel Hardy. This episode comes directly to you from the Hatch office here in Queensland's sunny capital, Brisbane, Australia. There, we spoke to Jan Kwak, who just happens to be the Managing Director for Hatch in both the Australia and Asia region. So you may or may not have heard of the Cross River Rail project, or how about the Sydney Aerotropolis, or even the $30+ billion project that is the Sun Cable project. These are only just some of the projects that Jan and his team at Hatch have been contributing towards in the past few years. Originally from Canada, where he completed his Bachelor of Chemical Engineering, Jan has paved a 25-year career from his time at Hatch, specialising a sought-after career in mining, energy and digital infrastructure. This episode is jam-packed with buzzing engineering topics such as the decarbonisation of mining, carbon capture strategies, mining tailings, sustainable cities, green hydrogen, green steel, and macro energy storage strategies, all of which are prominent areas in the future of this engineering industry. This episode is absolutely perfect for anybody looking for a career in either of those topics or just engineering as a whole. So sit back, grab your hard hat and prepare as we descend into the knowledgeable depths of Jan's mind and learn about what it takes to work in one of the most innovative but yet challenging fields of work. Jan, a very warm welcome to the Engineering Buzzcast. Thanks for inviting us over here to the Hatch office in Brisbane today. Really appreciate it.
Right on. Great to be with you guys.
So Jan, jumping straight into things, do you mind giving us a quick little rundown of the work you do on a weekly basis as the Managing Director for Australia and Asia for Hatch? And at the moment, what are some of the noticeable projects that you or yourself might be working on?
Yeah, great starting point. So that's why we all study engineering, right? It's because of the projects we get to do first. All of us, every job has some amount of latrine duty, but the really fun stuff, the best parts of my day are the days I get to do technical things. So thanks for starting with projects. Look, at Hatch, we cover three big sectors. Mining and metals is one, infrastructure is one, and energy is one. And there are so many interesting things happening in all three. Just to give you a bit of a simple high-level rundown, in mining, it's all about things like electronic materials, first of all. The world really needs to move to renewables, needs to move to electrification, and we need a heck of a lot of copper and nickel and lithium and cobalt to do that. Vanadium, rare earths, all those things. And there is a large number of projects under development or under construction now to provide those materials. So we've got 6-7 projects going in that space. There's a lot of work happening for us in decarbonization of mining. So that's a huge push. Again, we need these metals and materials in order to modernize society, decarbonize society. You need that copper. But we can't keep mining the way we always have. We need a new way to do it.
Yeah.
So there is a lot of work on how do you decarbonize the mining sector, and how do you do things without fossil fuels, everything from the trucks to the processing. Then there's also things like greenifying, even the call them the legacy industries, things like coal. There's coal seam methane and there's vent methane that needs to be dealt with. For the couple of cases where we still use coal in the modern economy, when we use it as a chemical, right?
Right.
So we should stop probably using coal as energy, but coal as a chemical where that carbon with 4 radicals is valuable.
Things such as like steel and stuff like that, I guess.
Steel or other things.
Yeah.
There's still some methane that comes out. You need ways to capture that methane and put that to a use, and hopefully that carbon ends up in a solid form and not in a gas form. So there's a fair amount of work to do there. There's interesting work in tailings and closure. We're doing, maybe later on we'll talk about it, but some really exciting civil earthworks.
Oh, awesome.
That just mind-blowing stuff is interesting. And then there's a couple of nickel smelters, copper smelters we're working on, which is when you basically melt rocks and get the metals out, which is still one of the best ways to recover metal. Infrastructure, really interesting stuff. We do a lot of tunneling work. We're working on the Melbourne Metro and the Sydney Metro and on the Brisbane Cross River Rail.
That's cool.
All of those things, really cool stuff. At the other end of the spectrum, one of the interesting ones is we're working on the Sydney Aerotropolis. So our town planning group or our urban planning group is doing a layout for the whole new second city centre for Sydney.
Sounds like something out of a comic book. Aerotropolis.
Oh yeah, that's what they call it. That's what it's called when you build a new city beside an airport. So there's going to be a second downtown Sydney out by the new airport.
There you go.
And then in energy, one of the really big signature projects you may have come across already is this Sun Cable project.
Yeah,
that is so interesting. That is a plan to produce, I think it's to the order of 16, 17 gigawatts of solar power in the Northwest Territories, and then send it by high voltage DC cable through Darwin, through Indonesia, all the way to Singapore.
All right.
Big job.
Yeah,
big tunnel.
Dang.
It'll be 15% of Singapore's power as renewables. Which is a big deal, right?
Yeah,
Singapore's
insane.
no way to get renewables. They don't have a lot of wind. They don't have a lot of sun.
Yeah.
So they're importing renewables from Australia. Fascinating job.
Yeah. Crazy. I mean, that's just the future of everything. That's the way it's going to go, right? So,
Yeah,
I mean, why not get it ready now?
I tell you, when we first looked at it, we were unsure of the business case, but we've been through it now, and it kind of makes sense. But to do that, it's in the papers. That's a $30-40 billion job. It's big.
Yeah.
Whoa.
And it's 4,000 kilometers, that cable, but in fact it's 4,000 times 3, because you don't just send a single wire. You need a return on the back. Two poles.
True.
So it's 12,000 kilometers of cable.
Wow.
That's a lot of cable.
We don't have that much cable in the world, it turns out. We have to build a cable manufacturing facility just to make the cable for that project.
You could build a cable to space for that. That's crazy.
Yeah, you're right.
Wow.
And do you have to? A lot of that's going underground too, eh?
Undersea.
Yeah.
On land, it'll be on land, but undersea,
yeah.
it's an amazing technology. And at the surface, as I described, it's an interesting one. But then, as you go down levels, there's so many problems challenges.
Yeah.
The 25 million solar panels. Wow. 25 million. That's a lot of panels.
How big is just one solar panel?
Well, like on your house, maybe the size of the table in front of us.
Wow.
Squared, right?
25 million of those.
25 million of those. It's kind of like painting the Sydney Harbour Bridge. When you install the last one, the first one's already needs to be replaced.
Yeah, wow.
Gosh.
That's
Amazing.
incredible.
Well, it sounds like you're covering a lot of aspects in your role at the moment, Jan. I mean, having to manage all that and direct all that at the same time must be a big job. So just quickly, could you just run us through what does the day in your life as your role as a managing director at Hatch look like? And what aspects or fields of engineering does this incorporate? You talked about some of the industries and sectors that this might incorporate, but for engineers especially.
Yeah. All right. So look, I'll just start with the kind of the hygienic parts of it. This is super important, right? I think on many of the guests you've had have talked about similar. Safety is the beginning and end of everything. In our business, as goes safety, as goes the project, as goes the business. So you need to manage that well. And for us, because we do studies and we build stuff and we operate stuff, you have to start with a safety culture in the office, right down to everybody in this building has to breathe safety, because the culture that we have in this office is the culture that we will share with the construction companies and with the vendors and with all the other people that we bring into projects. And eventually, because we're helping hire the people that will operate these facilities, the culture that they experience when they first join a project is the culture they'll bring forward. So it is so important that we have a super strong, mindful safety culture right here in the office. So that requires talking about it and being visible about safety. And
Starts at the root, really.
Yeah, bringing safety. We call it visible, felt leadership. That's a big deal. Another big part of my job is kind of pushing the culture, pushing positive change. Right, we're all engineers that just love to do stuff, and at its heart, many of us, myself included, what I want to create is positive change. I want to feel like I'm doing engineering to make the world better.
Yeah.
And how do you get a whole organization of people and all the people we work with and the contractors rallied around that? How do you create positive change? How do we make things better in the world? That's the driver for it, right?
Yeah.
And then when it comes to projects, I spend a lot of time with our clients. So we're an engineering services company. We design stuff. We think of creative new ways to do things. It's a really big deal for us to understand exactly what it is the government's trying to achieve, or a mining company's trying to achieve, or an energy company. What is really their business case? And then how can we innovate our way through, mind-blowing outputs that have never been done before. We engineers are like that. We thrive on doing things that have never been done before.
Yeah, totally.
Yeah.
Or even if it has been done before, do it better than last time.
Yeah, exactly. Yeah.
Right?
Yeah, it really is that drive.
Problem
Yeah.
solving.
That's what we love to do.
Yeah.
So I spend my time challenging people. How do you do that?
Yeah.
How do you push boundaries?
Yeah.
And maybe lastly, like, the best days for me are still the days I get to do technical stuff.
Yeah.
The day I get to crawl in and pile on and look at calculations or diagrams.
Chuck the
or
hard hat on.
something.
Yeah.
Chuck the hard hat on. Those are always the best days. And sometimes it happens once in a while. You see stuff you've never seen before,
Yeah.
and that's fantastic.
That's the best part.
That's
yeah.
the best part.
Yeah, yeah.
Yeah.
It's just something that makes you think about something in a completely new way.
Yeah.
Those are the best days.
Yeah, certainly
Yeah,
are.
definitely. Well, as this is called the Engineering Buzzcast, what are some things buzzing in your line, like your industry at the moment? There can be things around mining, infrastructure, energy, new opportunities, breakthroughs.
Yeah, there's all kinds of really cool stuff happening. It is so much fun to be in an engineering company doing all this stuff. A couple of things that might be fun to share. You read about it in the papers. Hydrogen is interesting, but it's not as simple as the newspapers lead you to believe. It's really still a little bit unclear of how hydrogen will be used, who will be using it, how will we make it. The idea of just get some renewable power, run it through an electrolyzer, and then you get your hydrogen. It's
You're like,
the next level down. It's a little bit trickier than that. It's number one, that doesn't scale very well.
Yeah.
Right. Yeah. Like, for example, we did a study in a paper exercise. If we wanted to convert all of the iron ore mining machinery in the Pilbara to hydrogen, stop burning diesel, burn hydrogen, how much would you need? Turns out that's a fair amount. And the amount of hydrogen you would need, I think, we calculated of the order of $10 billion worth of electrolyzers.
Wow.
Yeah, you'd fill football fields and football fields with electrolyzers.
Wow.
It's not that easy.
Yeah.
You can't scale that very well. And he also started to realize, well, okay, do I make my hydrogen in a centralized facility or do I distribute it? And
Sort
and
of build
that's-
like plants, I
and
guess.
but little ones,
Yeah.
or build them right at the end point. Maybe you do the electrolyzing right at the gas station or petrol station. Because if you build it in a central place and you can get economies of scale, then you have to pipe it all over the place. And how do you? It's hard to imagine pipelines full of hydrogen, which is a tricky gas.
Yeah.
LNG is one thing, but hydrogen is tricky.
Yeah. Especially in countries, I guess, where there's lots of natural disasters like
There's that.
earthquakes and things like
Let
high
alone the straight metallurgical problems. These are mechanicals, right? You get hydrogen embrittlement that it just changes the mechanical properties of your pipes and valves. So
It's interesting.
It's not easy. And then how do you use it? And if I have electricity, why would I turn it into hydrogen just to turn it back into electricity?
Yeah, exactly.
There's another balance there of all these losses along the way.
Yeah, the efficiency of it all, I guess. Like, is it really that efficient? And like,
So there's lots of work. But my point is there's lots of work in hydrogen to figure out what is actually the right business case and the right business configuration to use it. Another really kind of adjacent to that, really buzzy one is green steel. That is big. Green steel, green concrete. But green steel is trying to make steel without a blast furnace, right? So today you have these big blast furnaces that you load them up with iron ore and coal and you light them on fire, and after a while you get iron dripping out the bottom. That's pretty simplistic way to explain it. But
Yeah.
of course, the world wants green steel. We don't want to have to burn coal anymore to make that.
Yeah.
So we know that you can reduce iron ore with hydrogen or with maybe some other things.
Yeah, right.
How do you do that? Steel is huge. Steel is a big industry.
Yeah.
Most of it, and there's a lot to convert. We're just now starting studies with the major iron ore producers and the major steel producers of having a really good swing at how do you do that, and that's vital for the Australian economy. We're big iron ore producers, right?
Yeah.
Australia and Brazil are the two big ones, and our iron ore, we need to think about the Scope 3 emissions from that iron ore. So we need to figure out what's the right path to use our Pilbara ores to convert them in a sustainable way without CO2 emissions into iron ore or iron and then steel.
And I guess it's looking at the importance of the efficiency of it all as well, because it's only a finite resource.
Yeah.
We're eventually going to run out at some point, so like we need to make it as efficient as possible.
Yeah,
as well.
that's right. Because
Yeah.
things that might make sense in the laboratory, it's a different thing when you scale it up into a massive operation. It doesn't always work.
Yeah,
Doesn't
true.
always work. The chemistry might work, but the economics might
Yeah,
not.
the viability.
Yeah.
Other really important ones, tailings. Tailings enclosure is a big deal.
Yep.
Here in Queensland, we have 1,400 abandoned mines that are just under care and maintenance. There's as many more in the rest of the country.
Are they sort of recent mines, or are they dating back to say the gold rush era?
We're dating way back, and,
Yeah,
and there's
right.
more. We have a big issue, right? We got ERA Ranger, we have Gove here, and more. And there's a whole community building up now of what are some smart engineering solutions of how to properly close a mine. Not necessarily return it to nature, but prepare the ground so it can be valuable to the next user.
Yeah, right.
And it's interesting. Mines typically have around them infrastructure, roads, power, water. They typically have people living nearby. They have small industry nearby. So if with that configuration of land and those industries, what else can you do? Can you do a power plant? Can you do manufacturing? Can you do something else?
It's such an interesting topic, I guess, because it's the exact same problem that's existed since the beginning of mining, I guess. You've created this environment of activity that you've just described. So how do you develop something that, I guess, not only replaces that missing link, but also balances them efficiently as well?
So that's the closure. And then the tailings themselves, you guys know it. We've had all kinds of problems with tailings dams in the last decades, years, forever, actually. We can't do that anymore. So problems.
Just for those people listening at home, how would you define a tailing? So what's involved in that structure?
Well, simple example, right? When we mine copper, we typically mine copper at 1%.
Right.
That dirt we dig up is 1% copper. 99% of it is not copper.
Wow. Wow.
So when you see like a 400-ton truck drive by, it's got 4 tons of copper and 396 tons of dirt.
It's massive.
That dirt is tailings.
Yeah. It's a lot.
It's a lot, and it's wet, and it's subject to landslide.
Yeah.
It's sometimes toxic. It depending on a lot of things.
Yeah,
and it's interesting. The tailings challenge, we keep giving it to tailings engineers, which are lovely people, but they're the repair people. The problem is starting in the mine.
Yeah.
So how do you not make tailings in the first place?
Yeah.
It's the real grand challenge. How can you rethink how we do mining and how we do refining so that we don't generate tailings at all? Then we get rid of our problem. Then some other topics that are kind of cool. Grid stability, that's been in the news off and on for a while. The number of HVDC, so high voltage direct current connectors we need to kind of stabilize the grid is really, really important. We've got a whole group down in Sydney that just thinks about that. How do you stabilize the grid? Sustainable cities are interesting. I'm really excited now. So smart cities is one thing. So that's the Google cities and all that. That's nice.
Yeah.
But it's also a bit scary because of what we know happens when digital recognition goes too far and attracting people. But there's another industrial part of cities that is quite fascinating. If you think of a city as arteries and veins, cities bring all this stuff in, right? Fuel and food and materials and
people.
Construction stuff and people and sand and whatever. And then leaving the city, you got heat, you got sewage, you got garbage, you got recycling, you got, I don't know what else leaves. Now, if we really want to have a sustainable, renewable economy or a circular economy, you got to figure out how to cut down those recirculations into smaller things. So how do you industrialize on a city scale in a way that people wouldn't mind it being incorporated into their cityscape? A waste to energy plant or a recycling facility or a community garden or something like that. How do you design cities to be more engineering efficient while still being very livable? That's a whole new area that people aren't approaching.
I guess looking at it from like a mechanical engineering perspective, it's sort of similar to like a combustion engine where you're feeding it all these resources, keeping the engine nice and cool, but you've got all these exhaust fumes and rubbish just blowing out the back of it. Obviously, like you can't stop the exhaust, but I guess you can make it more efficient, cleaner, and stable, I guess. I think you could sort of apply that to the sustainable cities idea as well.
That's right. So, where we started out looking at, what are walkable cities or what are sustainable or green cities, now we're starting to think, all right, how do you make it into a process that works for environmental sustainability concerns, but is still highly livable?
Yeah. I guess that's a massive balance between politics as well and commerce. I mean, that's like got to be the biggest contributing factor. I mean, every engineer has those limits imposing on them because of those politics, it's such a restricting factor, but also it can be either restricting or the other half of the coin, I feel like it also advances it and pushes it a bit. So it's really interesting looking at it from that perspective.
Oh yeah, fascinating. And then I got one last one for you that's kind of cool. I think it's time, and there's a lot of buzz around this, it's time for nuclear power. It's time for that discussion to open up for us in Australia. I think to an extent we've forgotten why we're against it in Australia. It was something that came up in the 70s. And at the time, the view was that we shouldn't be involved in nuclear because there's the potential for it to end up in nuclear weapons.
Right.
Now, with geopolitics today, maybe there's something there, but technology's moved on, politics has moved on, and our understanding of the role of fossil fuels and stuff has changed, and where are we going to get our energy from? Nuclear's not crazy, so I'm not necessarily an advocate, but I'm saying let's open the discussion again and turn it over and look at it from different angles.
I think that's what you got to do in engineering anyway. You just essentially got to just keep re-looking at things over and over and over again because it's evolving. Like every 10 years, just go back, have a look again. Yeah, nothing's ever finished. You can't just put the book down and it's done,
That's right, exactly. We got to be data-driven and not politically driven. And neutral in this stuff. So I think it's time to open that up and look at it again, and that's happening. Every politician I get a chance to talk to, I talk to them about that.
What do they usually say? What's their response?
They say, we're not ready for that yet.
One day. Too complicated for them? Or?
It's a hot potato topic still.
Yeah, fair enough.
But if we talk about it enough, then it'll soften.
Yeah. So on this anyway, so like recognizing that society is attempting to make these monumental shifts towards a low carbon future across all industries, like you just mentioned, how will Australia specifically have an important role to play in all of this?
Yeah, there's a couple of things. We're kind of blessed with a lot of stuff. We're blessed with great minerals, and that's part of it. Everything we have in our modern world comes from either farming or from mining, ultimately, right? And all the things we want to have a long-term sustainable society, we got to be electrified. We have to have all these communications technologies to do that. We need these minerals. So Australia will be a big part of providing those base metals and minerals that we need to make all of the electronics we want to run our modern society. Our role in that is figuring out how to do that in a new way, in a sustainable mining way that has never been done before.
Right.
Not impossible. It can be done. If you chip away at problems, you get there. There's one. Number two is energy from renewables. We have a lot of renewables here. More than we realize. Incredible amounts of solar, incredible amounts of wind in parts of the country.
Yeah, even just recently the hydro dam being built.
Snowy too.
Yeah, and snowy as well.
Yeah, we don't have a hell of a lot of rain. Well, we do these days, it seems. But you're right. We have a lot of energy that ultimately we can export. So sun cable is an example of that. Eventually, being able to export, hydrogen is a part. That's probably my third one. Is that the hydrogen economy is bubbling up quickly here in Australia. And credit to the government, or at least the people behind the curtains at the government. They've done a great job of trying to configure how does hydrogen start to make sense for our economy. And just like today, we're the world leader in LNG export, we could one day be the world leader in hydrogen export. It's not exactly clear how that'll work yet, but you start somewhere and figure it out. It's like everything else.
I think once the ball starts rolling, I think that's when it can start to gain traction. It's like the snowball theory, it starts rolling, it gets bigger and bigger and bigger. I think that's exactly what's happened with renewables and sustainability in the past like 50 years. Initially, everyone's just like is a stage of denial and a stage of, well, I wouldn't say denial, but like not recognizing the importance of it. And once that starts rolling, companies start integrating it and it gets out there. That's eventually when the politics are like, oh, this might look good for me, so I'm going to push that as well. And I think that's what needs to happen with green hydrogen almost, I think.
That's right. We just got to find the right use case. So it isn't like anything, it's not going to be used for every single energy case, but there'll be a subset of cases where hydrogen is the right fuel. So let's figure those out.
So out of these emerging shifts among the industry, which can we expect to shape the trends of the sector for years to come? So like what is actually going to start this snowball rolling effectively? So is there anything new that you think will do this?
A couple of things come up. This whole area, I said it a couple of times in different ways already, but sustainable mining is a big deal. There's going to be work done in Australia, but that'll be big. But we can't keep mining the way we've always mined. We need completely new thinking on how that happens, and that's a big deal. That's a game changer when we get that far. When we figure that out, that'll spread all over the world, and that's the way society will continue to advance, is by having the materials we need to do stuff. I don't, by the way, think that space is the best place to start. It's on the list, but there's easier things to do before you get to space.
I think so, yeah. Just work with what's on the ground first before we get off into the air, yeah.
I mean, I'm a space nut too. I love it.
It's
realistically,
it's
I can see better business cases not in space. By the way, people also forget, right? If you bring a 1 billion pound nickel meteorite down to Earth, what's going to happen to the price of nickel? Right?
True. Yeah,
people forget about that. These asteroids they want to mine, when you create a surplus, then the price comes down. You can't do your 1 billion pounds.
I think that was like a thing proposed by NASA a few years ago. Was there's this big gold meteorite floating past or something, and they were like, why don't we just get a big magnet and just pull it in? And everyone's like, but that's just going to overload the economy. There's so many things to think about. It's so interesting.
It's all supply and demand, so it isn't necessarily the case that you can't take the weight of the meteorite and multiply by the price of gold or nickel and get the value, because you're just doing it changes the value. Anyway, that's one. Next one, kind of interesting. The macro issue, I think, is energy storage strategy, and some of that is working storage into not necessarily the big battery. That's the obvious one, but working storage into processes and into cities. Like maybe thinking about your car batteries as actually a part of the grid, and they can give and take.
Yeah, right.
In industry, there's ways to store power through intermittent use that we don't think about enough. Like a lot of my examples are mining, because there's lots of fruit for innovation in mining. But cooling mines, we spend a lot of electricity cooling mines. You can actually store electricity in an odd way by the amount you cool the mine.
Right.
On the days you have surplus electricity, you can cool the mine a couple of degrees more. And then on the days you don't have too much electricity, the mine will naturally heat up a little bit. What you're actually doing is
more
storing
lunch breaks
electricity.
On those days.
But the workers won't notice a couple of degrees, but you're actually storing electricity in an odd way. And there's lots of ways to integrate storage into the processes of heavy industry. If you just think about what they're doing, the water desalination, or the levels in tanks even, or how you manage all the different forms of energy. It doesn't have to be stored as electric energy in a battery, is my point. The other part, it's kind of an interesting breakthrough. I've always wondered, why does pumped hydro never seem to work as a business case? The simplistic idea is you have all this renewable power, and I'll just use that power to pump the water uphill when the wind is blowing, and then when the wind is not blowing, I'll let the water run downhill. Turns out the problem is a mismatch of size. Renewables generate more power than you need to fill your hydro dam. So the business case always ends up stuck with too much power that you can't sell.
Really?
You don't have nothing to do with.
Wow, that's an interesting.
Too much power.
Too much power.
Too much.
Yeah.
That's actually the problem.
Wow.
It turns out there's always a mismatch, and the hydro dam only ever really needs to cover a couple of days of time, and you have way more power than you need.
So it needs to be stored then.
It needs to be stored.
Yeah.
Stored or converted to something useful like hydrogen.
True.
So it turns out that if you make a little triangle, you make renewable power with a hydro dam and then a way to shunt the excess electricity off to something that you can get revenue from, like hydrogen or something else.
Yeah.
Then you got a business case. Suddenly your business case goes from marginal to profitable.
Yeah.
Speaking of storage, like obviously energy storage is a big issue at the moment. What are some of the best ways or new like upcoming ways that we'll be able to store energy in a more efficient manner?
Yeah, good question. There's, storage for what is what's important. The electricals on the listening in will get it. So you store it differently depending on how much you need to store and for how long. So for long duration, hydro is the way to go, or sometimes pressurized gas. There's a really cool configuration that they've been trying in the Great Lakes in North America, where they have these underwater balloons that when there's renewables, they blow up the balloons underneath the Great Lakes. And when there's no renewables, the water pressure of the lakes squeezes the balloon back down and runs the air backwards through a turbine.
That's so
Wow.
that
Cool.
is so smart. That is so cool.
That's crazy. So like a free compressor.
Yeah, it's a free compressor, but using the weight of the Great Lakes.
That is actually a really smart way to do things.
Yeah.
Oh my gosh.
Yeah.
That's so
The
interesting.
fish must be like, what's going on there?
It's cool, yeah. It doesn't work as well in seawater because just seawater is a miserable material.
Yeah.
Right? It scales and it causes problems.
Yeah.
It's corrosive, but lake water, not so bad.
Wow.
So that's the big ones, and then there's the medium ones. You can store it as hydrogen. You can store it as electrical in batteries, and then you have these. When you have only to store for microseconds or milliseconds, you can have flywheels and all kinds of things. We actually set up, we did this for a mine in northern Canada called Raglan Nickel Mine. We set up that we got them off of diesel by setting up a couple of wind turbines. And then we had 3 levels of storage. We had, how do we do this now? We had storage in an electrolyzer to make hydrogen for long-term use. And then we had batteries for medium-term use. And then we had a flywheel for seconds of use.
Wow.
Something like that. So we had to have an array of 3 or 4 different storage methods, all in the same, I guess you call it a bus bar, simplistically, so that you can cover all the different kinds of gaps in storage. you
Wow.
need.
So that's just depending on how much energy is being used
That's right.
that day or that week or that
And-
month.
Well,
or-
and then you get smart, right?
Yeah,
you
yeah.
get smart. You have weather forecasters, and you have some AI cooked in there that kind of manages your power based on the weather forecast, and that's where this word digital twin is actually accurate. That's what you need it for. The digital twin has to be able to predict the future and then model your process depending on what you anticipate.
Yeah,
Wow.
That's fun.
I imagine a lot of like simulation work and stuff goes into that
Yeah,
as well.
yeah.
Before you actually build it, the thing, you got to actually simulate it and see if it's actually efficient and will it work, that sort of thing, I guess. So
That's right.
It's
That's,
interesting to look at it that way because it creates a lot of jobs in that sense as well,
It does.
Yeah.
Digital twins are, when you get down to what they're really used for, it is fascinating. It is a combination of process control, and AI simulation and data learning.
Yeah.
Yeah, wow. Out of these emerging shifts in the industry, what are some things that we can expect to shape the trends of the future?
One will probably affect us more directly. Well, the energy storage will. Another one is recycling. Eh? We're not too good at that in Australia. I know we put everything in the yellow bins. But I don't know if you guys know, but I'm not sure that all goes necessarily.
Yeah, I don't know.
Yeah, I don't think so either. Yeah, especially when they do those big throwout days and they have all the stuff out in the front of the houses and the yards and stuff like that. I don't know. Like, there's a lot of stuff there that could just be reused again. Like, I've done that myself actually. Just gone around and picked up a bunch of TVs on those throwout days, and they're fine. They work fine.
Yeah,
I mean, if you look at places like India and China, for example, where they get a computer, they just pull every single little
Everything apart. Yeah, that's
component
right.
out of it. Like, insane. Like, the level that they go to just actually recycle something. It's like almost 99% of it is just recycled.
Yeah, I think there's got to be a trend coming up that'll affect all of us, that we think far more deeply about reuse, recycle, right? The materials we use. We're already seeing laws about throwaway plastic, like cookie containers and recyclable cups and that stuff.
What's your opinion on the plastic straw situation?
I didn't mind plastic straws for use, but I really don't like the wooden forks.
Yeah, right. And they hold the taste of what you just previously ate as well. It doesn't work.
We might have to just live with those, but
Maybe we should figure out new ways to clean the wood.
Yeah,
So that
Maybe.
that's
like,
what we need.
ways to treat it so it doesn't.
Maybe like have edible ones or something like that. Maybe
Edible
so
wood.
that they actually taste
Edible
nice.
cutlery.
For sure, there's lots of mileage to go, right?
Yeah,
Lots of innovation in the way we can organize, as I said earlier, cities, our own lives, to be participants in a circular economy and allow for things to be better recycled. That's big. That's the half that we keep forgetting about. And in a way, there's an industry push to keep using virgin material because that's their business. What at an industry level, what we'll see is that industry will become interested in recycling as a different way to get scarce resources, because we don't have enough mining material basically to get that.
I guess they're not going to be too happy about something coming along and replacing their industry, I guess is what you're trying to say.
That's right.
So therefore, by
They'll get on-
creating something that they can replace that with, and then convincing them to replace that with, I guess it's
that's right.
sort of like the coal problem, I guess, in a sense. Like if you switch off all the coal, I mean, you got all these, like this job vacuum essentially. So like you got to create something to replace it in a sense. I think you probably know more about that than me, but
they have to own their market. So the copper producers will want to own the recycling as well. And that happens in steel and aluminum already, but it'll happen in more.
I think it's just the passage of time.
Yeah.
We just got to let it just go, I guess.
And engineers thinking about it and making it better and finding smarter ways to do it.
Well, considering that, how do you propose Australia and the engineering industry here should focus towards, do you think?
In Australia specifically?
Yeah.
Well, look, we have these natural endowments of renewables and lots of mining, lots of good minerals. We need to exploit those to the betterment of humanity, right? And all the things that you need to do to achieve that. So my big theme is sustainable mining with no tailings, number one. Number two is an export energy economy based on the natural renewable resources we have here. That's a big deal. And to participate in, right, when you export, how do you kind of participate in the recycling part of all that stuff, right? We got to be responsible for the scope 3 emissions of all the stuff that we export from the country.
Because it's interesting, it's going off to these other countries, but are they actually going to recycle it efficiently?
Right.
Like, is there someone to enforce that or check that, or are there laws bounding that? It's such an interesting problem, and like there's going to be so many interesting solutions to come out of it. Like it's going to be exciting. I can't wait.
Yeah, definitely.
You've also mentioned previously, elsewhere before, that a balance of focus in social, environmental, and financial value in infrastructure will soon emerge. As a young engineer or industry member, how can we strive for this balance?
Yeah, that's a good one. So let's just talk about that concept first. That's a really big deal. Historically, we've always focused on the financial value, and it's still today when you go the economics on projects, you're generally calculating an NPV. And it's interesting that over time, of course, community or social and environmental aspects of industry have become important, and rightly so. I don't think today anyone doesn't agree that that's not important. But it's interesting that we still try and use dollars as a proxy for that, and we forget that it's a proxy. So we put a carbon tax, or we put a value on how many jobs you've created, and we feel like we've covered those two dimensions, and then we're done. Now put those numbers in the business case and let's move on. But it's not true. The carbon tax is not necessarily converting an environmental value statement into dollars that's equivalent to an NPV. So you need to, first of all, you need to measure it differently. You need to measure what is community value or social value really. And it's not jobs. It's the things that make society stronger. It's things like access to education, access to food and shelter, access to low crime, good government. Those are the pillars that will make a society stable, strong, and happy beyond the individual jobs you might be able to get. That's what's important. So you have to think about, in the things that we engineer, be it a statue in a park, maybe that's more art, a bridge across a river, or a train station, or a mine, or a factory. How is that going to, as we do that, how is it going to create social value in those dimensions? Just having more jobs is nice, but it's transient because it's not eternal. It doesn't last as long as that plant is there.
Yeah, it's only finite, I guess.
That's right. And same with environment. With environment, what are we really trying to do when we have not an environmental damage but environmental value? what is it? It's probably something, I still haven't really well defined this. Maybe some people listening have better ideas, but it's something about the vibrancy of the ecosystem, right? Of that whole cycle, the life cycle. If that is vibrant, then you're adding value. So through your actions of whatever industry you're doing, whatever you're building, if those life cycles are more resilient or more vibrant, then that's adding value. And if you're wrecking them, then they're destroying value. I guess what's always bothered me is that these environmental footprint calculations, the footprint should be able to go through zero, should be able to be negative. Like the object isn't to make your footprint as small as possible. Your object is to add value. To the environment, make the environment better as a concept.
Like a holistic approach of the whole system.
Yeah, that's right. So I think it's really important that engineers, what we can do is understand how our engineering designs and our engineering ideas, how they measure up in those three dimensions. And don't just fall for simple proxies of, well, my project's going to generate all these construction jobs, so that's good. There's lots of fertile ground in looking at those boundaries and really asking yourself, of all the options I have here, which ones generate value in the financial, environmental, and social dimension at the same time?
Wow.
And not just one of them, right? A truly sustainable company needs to generate value in all of those dimensions, or else you're not actually sustainable. Something's going to catch up to you eventually.
So effectively, I guess if you could like dumb it down in a sense and just look at it holistically, I guess you could just say that all like jobs are almost like a stimulant, sort of like this coffee. It only lasts a little while and it makes you happy. But like in the long run, realistically, it's not an effective solution, I guess. But whereas the environment has existed millions of years before us, so like we should be focusing on a balance between those, I guess, if we're going to exist in that environment.
I call that social value creation, and that has a legacy that can be beyond the life of the mine or the life of the factory. It's a big deal.
So, Jan, recognizing that you were once yourself a young engineer, shuffling your way through the industry, what choices or risks did you jump at that placed you in the position that you are today? And which ones would you or wouldn't you recommend?
Well, there's a lot of great question. Everyone's got war stories here, but I tell you, one thing that comes to mind, one of the most humbling experiences that you just have to do as a young engineer is stand in front of the thing you designed when it's built and it's about to be turned on. That is an awesome rush of adrenaline and fear at the same time. I was lucky enough to get that early in my career, and it was fantastic. Stuff that I'd toiled for 4 years designing.
What was that first thing?
That was a slag preparation plant and a leaching plant in Quebec to make titanium dioxide. And I had designed these fluid beds from scratch, and I'd piloted them myself. I designed them myself.
Wow.
With teams, but I'd it was my design, it was my equipment. And my goodness, the day I stood there and watched them get turned on.
It's so satisfying, though.
It is. But the moment before it's turned on, it's pretty scary.
That's what I just love about some of these engineering projects is that it takes so long to develop, but once it does come out, it just engages all of your six senses at once. That's why I love the aerospace industry so much, because like you get to be there in front of this jet engine that engages all your senses, the smell, the sound, you get to hear it, you get to feel it. Like it's such a satisfying thing.
It is every sense. It's fantastic. So that's one thing. The many people will tell you this, but you got to internalize it. It's really true. You got to say yes to anything new. Anytime you get to work on something that's never been done before, you got to do it. It's so much fun. The one other one that I don't hear mentioned enough, and I think it's super important, is at any given time in your career, be it you're in school or you're midway through your career, at the end of your career, you got to have a T-shaped career profile. And what that means is you got to have a base, like the vertical part of a T, that is deep in something. You got to be really good at something beyond what most people are. And you have to have the top of the T, which is a broad understanding of what everyone else does that's adjacent to what you do.
Yeah, right.
That's the best. And at any given time, whether you're in first year or postgraduate or at work, you got to assess, all right, am I deep enough in one or two topics that I can really claim I'm going towards world class? Like I'm one of a very few people that understands this stuff. And am I broad enough? And you recalibrate yourself over time. Sometimes you say, well, I got to get deeper at something, or I'm getting too myopic here. I got to focus on what are all the adjacencies to my
It's becoming
specialty.
an eye.
Yeah, it's becoming an eye, or it's becoming a line. I don't know, but you got. It's really important to have to take stock once in a while, and I've had to do that. I've had to recalibrate myself many times to just look at. I'm really enjoying myself, but darn, I'm getting to be pretty specialized. Maybe I should go just look at what some other things are.
Look at the top of the T.
Yeah,
I think I'm quite the opposite. I'm more of an O. Like I'm just I'm specializing in too many things and like just getting too much of a general thing. I think I need to get something that's specialized for me.
Pick a couple of things that you're really good at, because what happens, especially when you're a young engineer, you get known for something, right? If you're a generalist, you won't be known as the go-to person for anything. But you gotta make yourself known as the go-to person for a topic. It might be as simple as a kind of calculation that you know how to do well, or a kind of design, or a kind of, I don't know, a topic that you happen to have done as extracurricular course in microelectronics. At least you're the go-to for that. And then you'll build from that. Right? You'll build a reputation. People will get to know you, and by curiosity, you'll get pulled into more and more stuff.
I think it's more of like an identification factor too, like people look at you and instantly recognize, oh, that's your skill. Okay, we can chuck you in this area, or we'll take you on board, sort of thing. But also in a way, I think you need to balance that out. I mean, like you just mentioned, the T factor. So
that's a big deal. And then maybe one other interesting one that, kind of thinking about where do people struggle sometimes. You got to take stock of where you are on a learning curve once in a while, right? A learning curve is kind of like an S. And you always want to be in the steep part of a learning curve. And it's, once in a while, every couple of months, every year or two, you kind of look at yourself and you ask, am I still learning here? Yeah. And if you're not learning, move on quickly.
Go to the next level.
Go somewhere else. Well, I'm not saying switch jobs necessarily, but I'm saying ask for a new challenge.
You don't want to plateau a flat line or anything like that.
The way the whole engineering is a bit like this, there's a lot of wisdom involved in engineering as well. As soon as you're doing things that, I say this all the time around here, as soon as you're doing something that you know how to do, you're wasting a chance for someone else to learn that. Go train, show someone else how that works, and you do something you've never done before. Yeah. If all of us are working on things we've never done before, then we're all happy. We're all enjoying ourselves learning
I think
stuff,
that really
right?
comes down to like the essentials of leadership as well, giving those people those other opportunities to also thrive to get to where you were, in a sense. It's a really good feeling that way, because then everyone gets the same starting point and these like same opportunities, which is really great moving into like companies and stuff like that, because you can see that starting to develop more and more.
That's right. And then no one gets bored.
Exactly. Yeah, effectively,
Initially, what intrigued you when it comes to like pursuing engineering and the degree in general? Like, what was the driving factor in that?
Yeah, everyone's got a different story of how they ended up there. I originally was going to be a scientist. I liked science. I liked understanding why things are the way they are. Then one summer in university, I think it was, I got a job at a soap factory. And ostensibly my job was to help them with QA, QC in their lab and, measure stuff, sciencey stuff. But I got myself drawn to all the troubleshooting and all the fixing things and making things better.
Yeah.
In the factory.
Addictive, isn't it? Oh, it really is.
And it was kind of that summer when I really realized I'm a person that wants to make things better and have an impact. And understanding why things are the way they are is only half of it. It's capitalizing on that to then engineer something even better than it's been before.
Yeah. Soap factory, that's interesting.
It was kind of fun. It was kind of a small scale business. Run out of a big warehouse. They had contracts to sell cleaning products to schools and government buildings. And I got myself tinkering, and I started, because I understood enough chemistry to be dangerous, so I started inventing. I went to talk to their clients, and I asked them, so what exactly are you cleaning with these things? And tell me about it. Is it grease? Is it dust? Is it whatever it is? And I went back and I did some homework and figured out, well, what are the right kinds of surfactants and polymers that would actually clean that kind of a problem better.
That's the thing, right? It's understanding like what is actually this thing going to do. I think it's just asking those right questions will set you on that track and make you
ask the question.
Perform at 100% capacity effectively. If you know what it's going to be used for and what the idea of it is behind it, I guess that's what gets you in the end.
There's another interesting story from there. At one point, someone from the shipyards, I grew up in a town called Halifax in Canada, someone from the shipyards came down and said, by mistake, the mechanics ran diesel fuel through our water lines in the ship. How do I don't want to take all the piping out. How do I clean the diesel out of these lines? So I went back to the lab and did some homework and kind of synthesized a process of different stages of flushing they should do that should absorb the diesel into surfactants and flush it out. And I'll be darned, they followed my procedure and the water pipes were clean again.
That's so cool.
That's engineering.
That would have been so satisfying.
That just makes me recognize like there must be someone out there whose job it is to be a toilet engineer.
Yeah.
And flush things through and find the effectiveness of it. You just don't realize, do you, until you think about it more. Like,
so that's a small summer job, right? Just an engineering student for fun, but you know, you learn stuff from those little examples that you carry for life.
Yeah, being an essential engineer, fixing other people's problems.
Yeah, that's right. That's right.
Actually, on that, what approach would you take differently if you started again?
Well, I try and live my life with no regrets, so I wouldn't say I have any regrets. What would I do differently? I think I would do most of it exactly the same.
Would you focus on anything else differently? Or
You know what? Maybe I would have kept more track of. I remember doing. I went to university long before you guys did. At the time, neural nets and AI were just coming out. I would have probably stayed closer to that. That is really cool stuff. That we could have done a lot more with that. I also early on I had a chance to go to JPL to do a PhD. That would have been interesting. I kind of wonder if that wouldn't have been fun to do rocket science and rocket engineering.
Yeah, right.
But in the end, I thought I'm going to go work. That's kind of fun too, and that's been fantastic.
Yeah. You're either up in the air or underneath the ground. Essentially.
Yeah, no, that's right. That's right. Yeah.
On this, recognizing that your position is in such a dynamic engineering field, such as mining, so what would you say has been your favorite opportunity this far? Could be projects or overseas placements or even skill development, anywhere from between when you're at uni till now.
Look, that's lots of cool stuff. First of all, some interesting examples that are kind of almost extracurricular. One thing we're working on now, which is really interesting, we're working on a mosquito breeding facility.
Oh.
So where does this come from? The World Mosquito Program, it's called. These guys at Monash University have developed a bacteria that grows inside mosquitoes that eats malaria virus.
Wow.
And we're with them, we're developing commercial scale facilities to be built in Colombia, Brazil, Indonesia, to breed mosquitoes with this particular bacteria in their belly, so that when you release them into the wild, that bacteria will be spread into the native mosquito population.
That's crazy.
And
That's
eradicate
so
malaria.
cool.
Yeah,
Wow.
so
Wow.
interesting. So, our job is designing the facilities. So these have to be, biological hazard level 5 alarms facilities with really good HVAC, really good containment, because it's biological stuff. But it's interesting. These guys, they've already proven, they've eradicated dengue fever from Townsville from that same process.
Seriously?
That isn't well known, but that's these guys, the World Mosquito Program. And now we just got connected to them, and the engineers here love it. They get to work on interesting. It's charity work, but it's for an impact, right?
Yeah, wow.
Eradicating malaria in
That's
a different
massive.
way. And the mosquitoes keep living, right? You don't. Other programs destroy the mosquitoes. We just have the mosquitoes with different bugs in their belly so that they don't.
They're the one type of people that actually like mosquitoes.
Yes.
And it's interesting because it's not usually what most engineering is helping with. Like a lot of engineering is based around like physical stuff, but this is very helping the world in a different way, if that makes sense.
Oh, it's so interesting. I've been down to Monash to visit some of the science end of this project. And the people studying, how you breed mosquitoes, how they grow, how their genetics work is fascinating in biological engineering, I guess.
Yeah.
Another fun one is these seaweed programs. We've been working with the Climate Foundation on seaweed farms off the coast here, and some interesting things you piece together. First of all, these guys have proven that if you irrigate coral reefs with colder water from deeper in the ocean, you can regenerate coral. That's a big deal. That's a big deal.
Massive,
That's huge.
especially for Queensland,
For the Great Barrier Reef. For the Great Barrier Reef.
Yeah.
So that's kind of been proven, and they're working. We're helping them a little bit and figuring out how to do that on a massive scale. But there's cool engineering challenges in there. You got to figure out how to run these pumps that will pump cold water from deep to into the coral reefs from wave power. So you need some kind of a wave power pump.
There you go. You could even do those big balloon things again. You were just
something like
talking
that.
about. Something like that,
yeah.
Imagine the ocean, the capacity that has to squeeze something and pump it up.
But it's got to survive in the ocean.
Yeah.
Is the tricky bit.
Salt.
Yeah, true.
And then we're trying to design these hectare size platforms that you can can suspend in the ocean, in the open ocean, that you can grow seaweed on.
We were just doing this.
So funny.
We entered a competition a few months ago, and that was our proposition. It was we were talking about carbon capture techniques, and we were talking about how important it is for these platforms to exist. How did we propose?
We proposed carbon capture concrete beds, just like you said, to grow seaweed on, and then using that seaweed to like feeding it to like cattle and stuff, because it actually reduces their methane production by like a stupid amount.
It was crazy, yeah. And especially for Australia, that's such a big thing where one of our main exports is beef, you know. It's like, wow, that changes everything.
That's right.
Like,
that changes the scope 3.
Why don't we just do this right now? Like, it's like...
we were sitting there like, why aren't they doing this?
Yeah.
You're right. And when you do that feed, there's actually a business case. It's suddenly kind of
It's a new industry.
New industry.
And you can eat seaweed too.
The problem is making these platforms seaworthy when at the scale you have to be. So we've done a couple of designs for that. We're still not super comfortable. But, you know, there's a lot of wave action and there's a lot of force. The seaweed's a big deal. So that's some of the fun ones. Some other interesting things you get to do. You get to travel the world, of course. Engineering's a great one for people that are world curious. You get to see unusual things. I've been lucky enough because I've been stuck with one company all my career. So I've had the chance to work everywhere in the world and do everything we do. And you come across things, you know, you have a chance. I've been standing in farmers' fields in Myanmar talking to people about how they feel about, you know, their government and mining. Been in Ivory Coast during a coup. Went out for a project, you know, developed a really interesting project I worked on in northern Canada, building ice roads up to a new mine we had to build in terrible geological conditions. I learned a lot about ice roads that year.
Yeah. Is it sort of like off that show? What is it? The Canadian
Ice Road Truckers?
Ice Road Truckers, yeah.
Well, it's harder than that. Those guys drive around in Alaska, which is the ground that's already stable. This was ice roads we had to build in swampland. And things you don't think about. You have to filter that water you're going to build your ice road up from. Because any amount of colored material in that ice will absorb solar radiation and heat it and make holes in your ice.
That makes sense. So it's like a conductor in a sense.
So it's such a small thing like that.
Small little pebble of rock or piece of bark or a leaf stuck in your ice. Even when it's minus 20 degrees, the sun will heat that up and make a little hole.
What?
Yeah, incredible.
Wow. And that's one thing I really like about engineering, because it makes you think about all the little things that most people don't notice.
Yeah.
And when you take all those things into consideration, it can make or break a project.
Yeah, little practical things that engineers would realize that maybe not everyone does. And some other things that are just mind-blowing is when you get to build something that's never been built before. I've had a couple of chances to do that, to just, you know, develop a new process completely for making things never been done before. And see it stand there and experience that humility and thrill of watching.
We really just don't have enough time on Earth, do we?
No.
Like, realistically, there's just so much stuff to do and so many cool things to do. We just need more time on Earth. So it's so interesting. I just really wish we had more time.
Well, acknowledging that not every engineer succeeds without failures, what sort of hoops in particular have you had to jump through that have really built you up and help you get where you are today?
Yeah, you know, that kind of things I've figured out over time. It's none of it's technical. This is not about technical things. There's heaps of ability to learn technical stuff. It's all about attitude and energy and stuff. Like, I'm a generally positive guy, and most people try and be or are. And failures are learning experiences, of course. Or opportunities. So I've trained myself never to be afraid of failure, just to make sure that it's risk managed, right? That just do it a little bit. Don't let it go and fail quickly. You guys know that. That's pretty common knowledge these days. The working in teams is big. What's happened? You know, all of the single discipline problems have been solved, or 90% already. You're not going to find many pure mechanical or geotech or chemical problems, but there's all kinds of opportunity at the interfaces. And that's why the way I try and orient it, and the way we think about it here at Hatch is you focus on what's the challenge, and then you bring in all the disciplines you need to sort that challenge. And you'll find that nothing is necessarily only a mechanical problem. It's everybody. You need multiple lenses on it. So the real skill you need is teamwork, is an ability to be inclusive and just your instinct can't be that if we got a problem, you're going to fill a room full of mechanical engineers to look at it. You need to make sure you got diversity. You got to have, even beyond engineers, imagine that. You need to have lots of people looking at things, and if you create you have to learn to do this. We're not taught that in school, but you have to learn to create an inclusive environment where all those different voices are heard. And then you find amazing things. I've seen that happen so many times.
I love that so much. Just incorporating every single little voice, every single little opinion really does matter. And I think it really contributes to a project. I mean, that really leeches off of the past 30 years that we've developed in, that is communication. I think that's one of the biggest things that has just popped out of these past 50, 30 years. And I think we should just advance that even further. And I think we are, all these teams just coming together now. We're in an age where we're more connected than ever. We don't have to send pigeons over anymore, but we don't have to wait for letters to come back and forth. It's simple as just texting someone now. And I think that's something really great that's coming out of the engineering industry. It's just this collaboration, communication.
We're learning how to do that, and it's awesome. It's so much fun.
Oh, it's awesome. So on that note, anyway, do you have any advice for students considering engineering, or anyone still in university? And any advice for maybe any engineers listening, or graduates, or people working in the industry such as yourself?
Right. So let's start at people that are even thinking about it. I tell you, my view, this is the most exciting time to be an engineer that we've seen in decades or generations. Right. This maybe happened a little bit in the 70s. Maybe post-war, but it's happening again now. There are so many new problems that no one has ever thought about before. All this climate stuff is completely new. There is no, we're building up some knowledge now, but there's new problems, and there's new toys. There's new technologies that didn't exist before. We didn't have those tools before. So right now is such an exciting time to be an engineer. I can't think of a better age or era to be in it. And there's so much blue sky out there. There's so many new things that need new approaches. So that's first of all. So I absolutely advocate to everyone that will listen. When I go to high schools and stuff, I advocate to be an engineer. It's fun.
And it can take you so many places. Being an engineer is just the the one aspect. You can branch off into so many different fields with that.
Yeah, you bet. It's in fact, I wish more of our politicians and business leaders were engineers.
Just changing the mindset.
It would really help.
Oh, it really would.
It would. The next thing is, so that's first of all getting into engineering. Then once you're there, it's to conquer these modern wicked problems. They're called wicked, meaning that they're multidimensional, not easy. You need to really understand fundamentals. You can't be a cut and paste type or just copy and paste or just look up the formula and apply it blindly. You have to understand deeply what we're doing. That's where all the innovation comes from. So as you're going through your courses in university, just avoid that temptation to just push through and memorize it and move on, because you need those fundamentals to come back.
It's so tempting.
In the moment that I have for it is, but people say you'll never use it again. It's not true. You will. Everything I learned in university, I have used in some way.
Yeah, right.
Believe it or not, somehow.
Yeah, because it's that mindset you start to develop when you're in university, especially some of the courses you take, and you're like, is this really necessary? And it's chewing up a whole lot of my time, but I'm sure like speaking to people like you start to realize that actually is extremely
It comes back on you. It does come back.
I should have been paying attention in that class.
And it's not only second best, it's third best to be able to Google it, because that's just not adequate to have a deep understanding. After a while, you build up a mental model in your mind. You can connect dots better. You can't do that if you're Googling the answers to everything. You'll never be able to build the mental understanding.
I think you're offending a lot of medical people out there who just in their jobs go, just Google it real quick. Dr. Google says.
In the moment, in the bar, it's okay to Google it to find the answer. And then maybe one other interesting bit is kind of as you enter the workforce is to think deeply about the obligation of an engineer and the role an engineer has in society. In Quebec, in Canada, we have this iron ring business. I don't know if you guys noticed. I have an iron ring on my right pinky. That iron, in theory, comes from a bridge that collapsed in Quebec because the engineering was bad. And they recovered that steel and they made it into rings, and every engineering graduate gets one of those rings.
As a reminder.
As a reminder.
I was listening to something about this actually, and then every time, if you're right-handed, you write, and I think your ring is always touching your work.
On your signing finger.
So
So you're looking at it as you're signing. But that's the concept extends to all engineers in the world. I hold it at heart. We have an obligation to serve society as engineers, and we have to take that very, very seriously. Design safe things, design things that make the world better, have a positive impact on the world. That's our obligation. So in all the jobs we take, wherever it is technical people, or even if we're not doing a technical job, we have to bring our technical selves to that job and advocate for what's right. Don't let opinioneering get in the way of good, solid, foundational engineering.
Yeah.
So that's maybe the 3 bits there.
How do you stay focused, and what are your strategies to maintain a healthy work-life balance? And what recommendations do you have to people and tell other people who are struggling with this issue? It's quite a deep question, I know.
There's lots of. I'll just pick parts of that want to answer. How do you stay focused? I don't know how you do that. But there is good ways to declutter. The most therapeutic thing. There was an engineer, one of my mentors long ago, that told me this at a moment of my panicking. It is so therapeutic to make a list, a simple list. That solves so many problems for you mentally. A simple process. When you're feeling kind of unsure what's happening, just try and write down for yourself what's the problem, what are the possible solutions, and make that list longer than one. Make it multiple, and then choose of those what's the best option.
Or a combination.
Simple.
Yeah. And you get the satisfaction of putting that big green tick.
Yeah.
Done it.
So simple, but so profound and psychologically soothing.
Yeah. Oh, it is so much.
It's and you know it, when things get kind of crazy, you make a list of these are the 10 things I got to do, then strike them off. It feels great.
Yeah, it really is.
So don't ever underestimate that. And workplaces, it has to be fun. You have to enjoy what you're doing.
Yeah.
If you're not enjoying it, don't do it. Life's too short for that. And that's life advice. Anyone will give you that. It's cheap, but it's true.
Yeah. Any good books you recommend? Anything that you've read?
Oh, at the moment, I'm really enjoying anthropology type books, like Jared Diamond. Do you guys come across that? No. Fascinating stuff, kind of explaining why we are the way we are and what makes societies great and how they develop and where technology comes from in societies. Fascinating stuff.
Yeah. Because I think to be a proper engineer, you really have to have a psychological view on the world and what actually makes people think the way they do. Because if you've got this amazing idea, it's one thing just coming up with it. It's another thing also proposing it to somebody. And how do you do that on an efficient level? You got to understand that person psychologically, and you got to understand your audience psychologically, which is, I think, what engineers are trying to do with politicians at the moment. Like you just mentioned, got these amazing ideas, and it's like, guys, come on, it's just convincing.
Big deal.
What are some important skills regarding leadership and communication that you find to be beneficial when working within your team, recognizing that you're also a leader of a team, and in this workspace, these people here, what you say basically goes. But so how do you convince those people that what you're saying is the right thing, and also how do you get them to work in with you effectively?
Well, first of all, just generally, even before we think about engineering, because leadership in engineering is a bit special. But first of all, at the higher level, attitude and energy are so important in leadership. You can make we do this in Hatch here. We make a 4-quadrant box: high energy, low energy, good attitude, bad attitude. And in the bad attitude, low energy box is a cynic. Right, and in the top right quadrant, someone with good energy and a good attitude is a leader. And you got to just think through. If you have low energy but a good attitude, you're kind of a spectator. Right, and you got to kind of think: how do I organize myself to be in that leader box? Be a positive attitude and add energy to things. When you can find yourself there, you find leadership is normal. People want to follow and listen to, work with people that are in that leader box. Good energy, good attitude. People don't enjoy working with cynics and victims and people that are just negative. Be positive. So that's the general one. I do find that engineers are naturally skeptical, cynical people. So being a leader in an engineering organization, you do have to know what you're talking about. Generic managers don't often succeed in our world. You have to have been there, done that, and you have to pretty much be able to do most jobs yourself, or at least know how you'd approach it.
Yeah.
That's where that T is important.
That's
the
why that's
holistic
important.
approach.
Yeah.
That's right. The very few people will take you seriously if they can smell that you don't know anything about engineering.
Yeah.
So as people are building their engineering careers, first make sure you know what you're talking about. Make sure you've been there, done that, and then managing other engineers is much easier because you're starting from a point of credibility. Credibility matters in our world. It's amazing in stock marketing and stockbrokers. It seems like you don't need a lot of experience to do that, but in our world you do.
Yeah.
It's because we do very serious things.
Oh, I mean, it changes every aspect of our society, essentially. I mean, engineering
right.
is at the heart of it all, so you want to make sure it's correct.
Yeah.
Very, very
Sure.
start of the route, I guess. So how could people maintain those communication skills or develop those skills, do you think? Because recognizing, like you just mentioned, engineers can sometimes be a bit cynical in a way or in a sense.
Yeah,
So-
well, that starts with knowing yourself, believe it or not. Recognizing what your own triggers are. Recognizing, when you get nervous or when you get, hot-tempered. Why is that? And then it's amazing, but simple things like just taking a deep breath once in a while helps.
Bit of meditation here and there.
Just not reacting instantly, but allowing yourself to count to 5. The things we were taught as school children actually work.
You got to apply that toddler attitude.
It starts with self, and then this is well-worn path that psychoanalysts would understand, but engineers need to understand this too. That once you understand yourself and your own triggers and you're comfortable with that, then being able to empathize, being able to put yourself in someone else's shoes is pretty darn important as well.
Oh yeah, it really
right?
is. Yeah.
If you can't do that, you're also going to be in a pretty myopic one-way discussion. But once you've got those two down, then all you're looking for is, okay, so what are the principles of how we're going to work together to get somewhere? It's simple to say that. It's hard to practice that. So he's work on it, right?
Just work on it.
It's taken me a while. I'm just getting there.
Slightly, but surely, yeah.
On an end note, if you could solve one major problem in the engineering world that you have noticed within this specific industry or any industry, what would that be, and how would you solve it, do you think?
You might have noticed through this discussion I've struggled with just one of anything. So I'm going to give you a couple of things I think are kind of interesting. First of all, you know what I think would be a breakthrough that would help lots of different things is better tunneling. Actually, it's more of a mechanical problem and geotech problem maybe. But so much mining, city infrastructure, transport would be better if we could do tunneling cheaper, faster, better.
Really?
Yeah, we're not there yet. We have some pretty cool tunnel boring machines. But there's so much uncertainty. It's still as much black art as it is engineering and science, how you do that. By the way, if you ever get a chance to visit a tunnel boring machine, take it. It is unbelievable.
Oh, really?
Oh, awesome stuff. Oh, yeah.
Yeah.
Oh, yeah. The forces involved and the way they move is
They're a bit scary looking, aren't they? It's these big, massive machines, all these drill bits on the front. Bore these massive tunnels. Like
how much better are the cities in Australia because we have tunnels?
Totally.
It takes the cars off the streets.
Especially Sydney, that tunnel underneath the bridge and everything like that.
That's right. How much better, you need better tunnels for hydropower. We need better tunnels for transport, for more efficient mining. It's way too expensive. So I think if we had better tunneling technology, that would go a long way. That's number one. Number two, I think there's huge gains that we can do here in Australia on sustainable mining. Especially, we need to kind of take over mining from the mining people, or the mining people. We had to think of mining happening when you first break the rocks, and how do you get those atoms that you like out of the mine without moving all the rock you don't need. That is, there's so much technology
complex
in that.
problem, hey?
Oh, it's complex, but it's interesting. Yeah. So those are two that I think if you could do those, you're solving a lot of world challenges in one foul swoop. The other one, not even technical, one thing I've noticed that would be really cool is if we could get more engineers involved in business and government management and leadership. We don't have enough. We don't have enough technically minded, data-driven people in the policy rooms and making strategy decisions. We have people that don't understand the basis of the engineering, making calls, and isn't always right. I would really, really like to see engineers be far more prominent in society and take a far more active role in driving where we're going in society. I think that's big.
How do you propose that could potentially happen? Do you have anything you've thought of? Or?
Yeah, well, we need to inspire engineers to be interested in the communities they're in and society and in government.
Yeah.
I'm not sure if it's true today, but I remember when I was in university learning a statistic that in Japan, for every one lawyer, there's 10 engineers, and in the US, for every one engineer, there's 10 lawyers.
Oh, wow.
There you go.
Yeah.
For us.
How different is a society?
Yeah.
Wow.
When there's more lawyers than engineers or more engineers than lawyers.
It's interesting. It's showing, is that either for money or is that actual interest? It's
I don't know.
It's an interesting one.
One group argues a lot more than the other, probably.
Yeah, probably. Yeah.
So taking an interest, and I think it'd be fantastic to have more engineering-minded people in government making policy about stuff. And
I think so.
the decisions we make around, making the country sustainable, reducing CO2, climate resilience those are technical challenges.
Yeah.
We need technical people in the policy room at the time they think about that.
With that holistic approach,
I think so. I think so.
Do we have an engineering minister? I'm not too familiar with that. I know we have like the defense ministers and all those other sort of ministers, but is there one for engineering?
No. We have a chief scientist. Right?
Oh, okay.
It was Alan Finkel. I forget the name of the person that's taken over now. We have a minister for industry.
Okay.
And those, politicians are the elected person, and then they have a group of people that sit in the government offices that have, more permanent jobs there that think through the policy. Those people, it'd be great to have a good representation of engineers
Would be.
in that group as well.
Imagine if the Prime Minister was an engineer.
Yeah, what happens?
That'd be interesting.
Actually, one more thing. What are some opportunities that students can have in Hatch?
Yeah, well, very directly. We take in a lot of students every summer for internships, of course. That's the best way. We're trying our best to get more involved the other way in the universities. So I'd love it if more of our people gave guest lectures, etc. I'm very big on that. We have to give back to university as much as we need to create opportunities for university people to come in with us. And we come talk to us. There's Hatch people floating around everywhere. You'll find they're all friendly people.
Anyway, Jan, thank you so much for your time.
It's been really interesting.
Thanks for spinning a yarn with us. Appreciate it. But yeah, thanks for your time. I'm sure a lot of people will really gain something from this episode. So
Good.
I feel like you provided some really good insight into what people typically don't know about the engineering industry as such. And I think it really helps having people like yourself advocating for futuristic but sort of yet contemporary solutions to engineering problems. But I'm sure there's so much work to be done in the mining sector, which is really only just a portion of the engineering industry on a whole, I guess.
Lots to do, certainly at the moment, lots to do.
Yeah. Well, extremely interesting. Thanks so much once again.
Thank you very much.
Yeah.
It's been a pleasure meeting you guys. A really fun discussion. Thanks for that.
Awesome.
Good to hear.
Thanks for that.
All right.
And with all that said, if you've enjoyed today's episode, please don't forget to share this with your mates or colleagues who also might benefit from these discussions as well. And if you can, just leave an honest review or rating on your preferred podcast platform. So with all that said, you've been listening to the Engineering Buzzcast with your hosts, Jacob Primus and Daniel Hardy. And until next time, see you in the next episode.
See you in the next episode.
See ya.
The top job is that of the engineer. This requires a great amount of ability and training in mathematics. And you should have some courses.